All right, so today, as I said, we are going to shift our attention to intelligence testing, right? Yesterday, you looked more at the theories of intelligence. Think Spearman, Thurston, Gardner, and Sternberg, right? Those different approaches to what is intelligence, right? And you watched the documentary that broke down that general intelligence, that G factor, a little bit more. Today, we're going to shift on so we know what intelligence is, or kind of like how it's defined, but how do we measure it, and where did those measures come from? So that's kind of the goal of today. I'm actually going to have us start out by just watching a short Psych or Psych-Sci or whatever it is with Hank Green. That'll give you guys kind of like an overview of IQ testing, and then we'll dig into the actual definitions and the specifics, getting into a little bit more nitty-gritty detail above and beyond this intro video. Again, the goal here just being introduce you to some of the ideas, and then we'll dig deeper and take those notes. So here we go. Let's watch that real quick, and then we'll dig in.
When people talk about smarts, intelligence quotient, or IQ, always seems to come up. People love to bring up how Einstein had a genius-level IQ of 160, and to join Mensa, you need to have an IQ of at least 130. But is IQ even a good way to measure intelligence? Well, that depends on how you define intelligence. IQ scores may be a useful shorthand to talk about education strategies for big groups of people, like when discussing public policy. But IQ can be affected by a lot of factors, even things as subjective as your motivation while taking the test. The first sort of IQ test was invented by the French psychologist Alfred Binet in the early 1900s. A law in 1882 aimed at egalitarianism said that any healthy child had to go to school and learn the basics, like reading, writing, arithmetic, history, public policy, and the natural sciences. The law even included a special consideration for children with disabilities, like deafness or blindness. But the French government acknowledged that not every kid would be able to keep up with a normal curriculum, for lots of possible reasons. So Binet and other psychologists were commissioned to create a standardized test to measure how different kids handled their schoolwork. Along with Théodore Simon, Binet developed the Binet-Simon test, in which children would answer a series of questions until they couldn't anymore. That way, kids could be grouped in classes with students with similar scores, instead of relying on their age or the subjective judgments of teachers. In the next decade or so, this scale was revised for use with both kids and adults and renamed the Stanford-Binet Intelligence Scales. This popular IQ test is still used today, along with other standardized tests that are meant to measure learning ability, sometimes defined as how quickly and easily we learn new things. On early versions of the test, IQ was calculated by taking a person's score on a standardized test, dividing it by their chronological age, and then multiplying the result by 100. In more modern versions, you're basically ranked against other test takers. The scores of a group of people are scaled so that 100 is the average, and your IQ score is determined based on where you are in relation to that average. But here's the thing, whether or not IQ tests actually measure your intelligence depends on how you're defining intelligence. In simple definitions, intelligence is the ability to learn new things or adapt to new situations. But the definition can also include the ability to use logic or reason or to think abstractly. These definitions are all focused on intellectual capacity, which is how intelligence is defined by the American Psychological Association. And they don't include other kinds of intelligence, like social or emotional intelligence, or things like creativity or self-awareness. The Stanford-Binet test, for instance, focuses on testing 5 main categories of information: baseline knowledge, basic mathematics, visualizing objects in space, working memory, and fluid reasoning, or the ability to solve new problems. So depending on what you're trying to understand about someone, IQ tests might be useful, or they might be a waste of time. It turns out that your IQ score can be affected by a lot of different things, and because intelligence is so complex, we're not sure how strongly different factors might affect it. There's some evidence that says cognitive abilities are somewhat heritable, meaning there might be some kind of genetic component to IQ, but it's not that simple. Recent studies have shown that IQ tests are affected by motivation. For example, one 2011 meta-analysis found that people who are offered cash if they do well on an IQ test scored higher than people who weren't offered anything, like up to 20 points higher for just a $10 reward. That is a huge effect. And we know that motivation can play a role in other things, like your grades and your career path, that could be wrongly chalked up to just an IQ score. IQ also seems to be affected by environmental factors. Cultural values can influence your IQ scores. For example, a kid who grows up in a community that prizes storytelling might do better on verbal sections of the test or problems that require you to remember and reuse information. How much education you get and the quality of that education may have an effect too. Kids who miss school because it's hard for them to get there, or who attend schools without many resources, tend to score lower than their peers. Even your family environment can affect your IQ, like whether you grow up in a low-income household or whether you experience a lot of trauma as a kid. So like a lot of things, IQ seems to result from a mix of nature and nurture. There are just so many factors that affect your learning ability as you grow up, from the environment you develop in before you're born to things like education opportunities and family dynamics. But psychologists seem to agree that one thing that seems to help people with learning and academic achievement is thinking about intelligence as a thing that can change. So IQ tests aren't anywhere near perfect or comprehensive, but they can help us predict how people might learn in the near future, which can make a difference in the support they receive. For instance, IQ scores can affect diagnosis of intellectual disability, which can inform public policy about education programs to support different students. It's understandable why it's valuable to have a standard way to sort of measure intelligence, like when it comes to making these general policy decisions. But it's also easy to see why IQ tests have been surrounded in controversy too. There's a lot we don't understand about intelligence, and a lot that an IQ score can't tell us about a person or groups of people. So while IQ can be a useful shorthand in some cases, it is not something that is set in stone, and do not let a number define you. Thanks for watching this episode of SciShow Psych, brought to you by our patrons on Patreon. If you would like to support all the SciShow channels, you can go to patreon.com/scishow. And if you want to keep exploring psychology questions with us, you can go to youtube.com/SciShowPsych and subscribe.
So there you go. Hank Hank and I are on a first name basis. Hank Green on SciShow. He obviously gave kind of an overview of what is IQ. He mentioned both the Stanford Binet and the Binet-Simon tests, which we're going to get into here in a little bit. But I do just want to break down first talking about like intelligence and brain anatomy, because obviously, if you think back to not obviously, but if you think back to regular psychology, we talked a little bit about phrenology in chapter 2, right? When we talked about neurobiology and the makeup of the brain, and you guys, I can't remember if it got blocked by YouTube, but there was like a trailer clip from a movie where the woman rubs his skull, and they feel bumps on the skull, and they think that it is associated with different mental capabilities, right? Obviously, when we're starting off way back when psychology first was being studied and they didn't have the ability to do an fMRI or even an EEG, right? There was a lot of assumptions that the size of your brain correlated with intelligence level. They thought that overall brain size could lead to higher IQ, or what we call IQ now. But there is some research out there that says that overall brain size does seem to correlate with genius. The size of some brain regions, specifically the parietal lobe, seem to be more prevalent in that. High brain activity in the frontal and parietal lobes, right? Obviously, you think about cognitive psychology and decision making happening in your frontal lobe. If you have extra gray matter, which are the brain cell bodies that seen as more brain surface area, can lead to correlations with genius, and extra white matter leading to high connectivity among different regions. With that all said, activity in the front part of the frontal lobes organize and coordinate information, being in shape, using less energy to solve problems in the brain of normal people. This all takes place when intelligence in action seems to take place in the brain, right? With that said, they also did research. They would when people died, they would pull their brains out, think Frankenstein, keep them in a jar. but like they actually like would do that, and they would study brain size. And there's also geniuses such as Albert Einstein who had like an actually really tiny brain, right? Comparatively to the normal human. So just kind of keep in mind there is some research out there to say that brain size correlates with quote unquote genius, but there's also research out there that shows that that's not always the case. Not all geniuses have big brains, but most people with oversized brains might have elevated IQs. So just something to think about as we're kind of getting started with that foundational understanding of intelligence testing. Before we kind of move on here to looking at Sir Francis Galton. Obviously, this early to mid 1800s, we see kind of this definitional intelligence testing really taking shape or starting to be looked into. He did a lot of research looking at genes and family line, right, with the assumption that intelligence leads to biological capacity, or like our ability to procreate, right? Thinking again, Charles Darwinism, survival of the fittest, that evolutionary psychological approach, right? And if we're intelligent, we're more likely to pass on our genetic information, our genetic code. He did a lot of looking at reaction times and sensory acuity, so like being able to respond to whatever it might be. In terms of like if I tossed you a ball, could you catch it really quick? Like kinesthetic, almost reaction times. And because of some of this research and this evolutionary approach to what intelligence meant in terms of being able to procreate successfully, right? We see the start of the eugenics movement, and essentially this is saying like the government and people should take control of those who are procreating. So for example, positive eugenics says highly intelligent people are encouraged to have children, but negative eugenics, if you think about like the Holocaust and Hitler's whole agenda to get rid of the Jewish population and other minority groups, right? The goal there was to not have them procreate because he wanted an Aryan race. That would be an example of negative eugenics, because he would say like lower intelligence should be discouraged, or obviously in the case of Hitler, right, exterminated. So Sir Francis Galton kind of started off this discussion or research into where intelligence comes from, what it is, and it leads to kind of this eugenics movement until a little later on we see Alfred Binet, who Hank Green mentioned in the SciShow intro video. Alfred Binet came in because there were kids that were struggling with their learning at school in France, and so he and Simon came up with a test in 1905 in order to test a collection of higher order mental abilities that were loosely related to one another. Right? The idea here being intelligence is nurtured. I'm sure you've heard in other classes from other teachers this idea of a growth mindset. It was presented by Carol Dweck. She's an educational psychologist, and she really advocates for this idea that intelligence isn't stagnant, right? You're not born with or without it, right? It can be changed and it can grow, and it can like be diminished as well, right? I always think about intelligence. Somebody told me this when I was taking a class in college, specifically as it pertained to neurobiology, but they were talking about intelligence as like a rubber band, right? Like you can stretch it pretty far, but you can only stretch it so far, right? So like biologically speaking, we're born with like certain capacities, but what we do with those capacities can be really, really significant on one's potential IQ. And so with the Alfred Binet Simon test, they came up with this idea of mental age, right? And with our understanding of mental age, it's important that we kind of recognize the difference here and just kind of take a break, step back, right? Historically, Binet Simon test, but what are those types of tests? There are different types of tests. One is an achievement test and one is an aptitude test, right? Achievement tests measure what you already have learned. Examples include a literacy test, a driver's license exam, and a final exam in our psychology course. And an aptitude test attempts to predict your ability to learn new skills. So for example, like this says, your psychology final is an example of an achievement achievement test. What have you learned? Show me what you've learned. Show me the mastery that you've gotten over this content. An aptitude test says, well, what are you going to do in the future? How are you going to perform in the future? Tests like the SAT or the ACT, right, are trying to predict college preparedness or your ability to be successful in college. And therefore, they would be considered an aptitude test, right? They're trying to see, like, what are you going to be potentially able to do in the future? So the question is, if the SAT is an aptitude test, should it correlate to IQ, right? Your gut would say, yeah. I mean, if the goal is to figure out, if the ACT or the SAT is trying to tell me how I'm going to do in college, if I have a higher IQ, I'm probably going to do better in college, so I should do better on the SAT or ACT, right? And they do find that there are correlations, obviously, within this kind of idea here. There is a correlation, but the correlation really isn't as strong as maybe it should be. Looking at this graph, you can see, right, remember this is an example of a scatter plot graph. This is very commonly used in our statistical studies, which we'll look at here. In the future, we'll do a little bit of stats review. But each of these points represents a single person. So if you're looking at like this point right down here, right, this person scored, let's say like a 780 on their SAT score, and they have maybe like an 88 IQ score, right? So each of these are individual people. And it's interesting to say that although there's a strong enough correlation to say that this is statistically significant in this particular sample, the SAT separates out some above average IQ people from others. But when we're looking at it, in other words, IQ scores do not do a good job of distinguishing among people with IQs over 120, right? So here's that 120 line. There's quite the range in this group of people. This part doesn't seem to be super correlated, right? And so it's difficult once you get to that 120 mark. The correlation doesn't seem to be as strong. So it's interesting just to kind of think about the relevance behind SATs and ACTs. You guys are all in the heat of that. Obviously, it's been tough to get the ACT completed with COVID and whatnot, but just something to think about, right? The difference between achievement tests about stuff you've learned and aptitude tests about how you are going to be successful. Because we talk about the Stanford Binet test then, right? Once they modified the Binet-Simon test from France, it came to Stanford, obviously the University of Stanford, and they kind of made some adaptations to make it a better, more effective test of intelligence. But this would be an example of an aptitude test, right? Their goal isn't necessarily to test what you've already learned. Their goal is to figure out like where your potential is as it pertains to intelligence, right? If we think about one definition of intelligence, we're thinking a reference to the ability to adapt and handle challenges, and it is not the measure of existing knowledge. Right? By this definition, intelligence would give one more aptitude, more likelihood of performing well in the future. Okay, so again, looking at the Stanford Binet scale, this was created in 1916. Just to put into context, the Binet-Simon test was created in 1905, and the goal here is to find an intelligence quotient, child's mental age divided by the child's chronological age. This is used widely in the United States, but not as much as it was in the past, right? Because again, we have an understanding and we know that IQ isn't just like a stationary thing, right? So while you can take an IQ test and you can get a glimpse of like what your potential capacity for intellect is, right, it could change. So with that, we're just going to do a couple of examples in terms of trying to actually calculate mental age here. And yes, you will need to be able to do this for your test because it's important as we're trying to determine what exactly is IQ and how do we measure it. Like understanding the mathematics behind that is pertinent to our understanding. So go ahead and look at these 3 examples. Pause the video, take a second, try and figure out what those mental ages are. Just remember, intelligence quotient is a child's mental age, right? Hey. Mental age divided by their chronological age times 100, just so you have that as a reference. Okay, I'm going to go to the next slide. Hopefully you paused it. If you're not done yet, I'm going to go to the next slide and it's going to show the answer. So number 1 has a mental age of 9, 2, IQ of 92, and then the third one, your mental age and chronological age are the same. So hopefully you had a chance to work through these. You got them right. If you didn't get them right, you can figure out why. But make sure if you do have questions about this, jot it down in your notes and stay on the Zoom next time so that I can go through it with you, okay? So with that then, we're going to transition from the Stanford-Binet test to looking at modern intelligence tests, specifically the Wechsler tests. David Wechsler introduced standard deviation to the IQ model. The reason that this was so important is because it developed norms. So instead of just saying you're a 120 and you're a 100 and whatever, it provided more normative understanding as to where you fell along averages. So the Wechsler tests, you have the WISC-3 for children and the WAIS-3 for adults. And like I said, they added standardization to intelligence testing. They took all raw scores and converted them to standardized scores so that we could find a normal distribution, mean of 100, and the standard deviation is 15. One thing to remember, which I already kind of referenced if you had me last term for our studying of testing strategies, right? We talked about the 68, 95, 99, 7 rule. This comes into play again pretty significantly here. Like I said, we're going to do some stats review when we get back from Thanksgiving break, but for now, let's attribute some of these statistical ideas to standardized testing as it pertains to the Wechsler test that we talked about. So for example, standardization means that test items piloted on a similar population of people and norms have been established. Norms are developed by calculating the average score achieved by a particular group, and then each person's score can be compared to see how it differs from people who have taken it in the past, right? An example of this then would be say for the AP Psych test, it was given to college freshmen as a final exam of their Psych 101 classes in order to establish some norms known as the standardization sample. From there, standardization, like I said, means that items have been piloted on a similar population of people and norms have been established. So looking here, like I said, that 68, 95, 99.7. We know that 68% of scores are going to fall within one standard deviation of the mean, right? Our mean right here is 100. One standard deviation this way, one standard deviation this way. We know that 95% of scores fall within 2 standard deviations. And then lastly, 99.7 are going to fall within 3 standard deviations of the mean. Like this says, norms are developed by calculating the average score achieved by a particular group, and then each person's score can be compared to see how it differs from people who have taken the test in the past. All right, so that is the definition of standardization and why it's important, but it gives us kind of some context in which to look at, instead of just saying, like I said with the Stanford-Binet test, you scored a 110. Okay, what does that mean? Is that good? Is that bad? Just because my mental age is higher technically than my chronological age, what does that tell me about how I compare to others, right? That's what standard deviation does. And again, please do not forget that 68, 95, 99.7 rule in terms of where these scores are falling along the standard deviation curve. So with that said, the next 2 slides just have a couple of example Intelligence tests, take them, don't take them. I would suggest to take them because it's just interesting and it gives you some insight into what these tests are like and what kind of questions they ask. But these are two just examples of, the first one was the Stanford-Binet IQ test, and then the second one here is the WAIS for adults. Another thing that I did not mention about why this WAIS for adults is important is because like mental age makes sense when you're talking about like kids, but once you turn 30, right, that will be me next year. Once you turn 30, mental age doesn't really matter. Like everybody who's around 30, most of us have like completed school, have gone through what we're going to go through in terms of our education. Our learning is taking place in the outside world, and our mental age doesn't really change, right? But what is changing is our chronological age. So we see those scores tend to fall at a certain point for people because their mental age generally stays the same while their chronological age goes up. I forgot to mention that. But anyway, take these two practice tests just for yourself. It's just kind of interesting, again, to see the types of questions that are asked and then also kind of where you would fall, right? If we were in school, I would have us all plot, everybody kind of turn in an anonymous slip, and we would plot exactly who fell where. So we'd likely have a few here, maybe one couple here, maybe somebody's really out there, probably have a couple here. We'd have skewed data. I would guess we would have skewed data just because we are in an AP Psych class, so our average would be a little bit, sorry, I have never drawn a worse bell curve in my life. We'd probably be a little bit skewed to the right just because we are in an AP class and you have selected to be here. But it's interesting to look at. We are going to talk about reliability versus validity, but when we're talking about those two practice tests that you guys maybe took, are they reliable results? Are they valid results? How do we tell if something's reliable? How do we tell if something's valid? And furthermore, how do we know that like these tests haven't changed over time, or that like general intelligence levels haven't changed over time? We don't. Ha 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 ha. Gotcha. That's exactly why standardization is so important. One, to establish norms, but also to establish the opportunity to engage in re-standardization. This is retesting a sample of the general population to make an updated or accurate comparison group in case people are smarter than they used to be when the test was first made, which, according to the Flynn effect, is true, is the case generally most of the time, right? The Flynn effect performance on intelligence tests has improved over the years worldwide, right? In developing countries, in developed countries, across the board, we have seen average IQ scores going up over time. You can see that with this graph, right? In 1910, the average IQ score was a 75. Now we see the average IQ score edging closer to 100. And when you think about it, right, that kind of makes sense intuitively, just based on the amount of information that we know and can share. And like, I mean, if you were in my psych class last term and term 4 of last year, right, you did that activity, Dear Senior, and you talked to different people from different generations about their school experience, right? Just thinking about that, how much work you guys do compared to your parents and your grandparents, right? It's very different. We also know that things like nutrition, education, parental involvement, we now see smaller families. These could lead to improved intelligence as well, right? Think about in like the 1920s, people had like 6, 7, 8 kids. Now we're seeing many more families having 1, 2, or 3 kids, right? And so they can focus more on those individuals and help foster that intelligence. But what's important to think about above and beyond this is really the implication of the Flynn effect, right? Test scores need to be adjusted so that average means like the average score of today's general population, okay? So we need to be able to re-standardize and adjust those norms that the Wechsler tests put into place with standardization, right? So that we are comparing, in fact, updated data. With that said, Whoa. So with that said, it goes to show this restandardization process. If you took the same test and got exactly the same score over time, that score may shift. So real quick, I just want you to write, like, maybe on your notes, try and answer this question. You took an IQ test last week and got an IQ result of 120. And then, after decades of the Flynn effect, the test got re-standardized this week. Today, you took the same test and got exactly the same number of items correct. Your new IQ score is likely to be A, here, I'll write this down. A, oops, I didn't like that. Eek, sorry team. A, 105, B, 120, or C, 128. Here it is again. You took an IQ test last week and got an IQ result of 120. And then, after decades of the Flynn effect, the test got re-standardized this week. Today you took the same test and got exactly the same number of questions correct. What would your new IQ score most likely be? The correct answer here is going to be A. And the reason for that is that IQ is now standardized so that your raw score is compared to a post-Flynn effect population or a smarter population. Compared to this newer, smarter group, your number of items correct might not seem so great, and in fact it will drop. It might even no longer seem to be above average. So you got a 120, but once it was re-standardized, right, you took the same test, got the same number correct, the actual IQ score then is going to be lower because it's being compared to a smarter population of people. Okay, again, through this kind of content, make sure you are writing down any questions that you have so that you can ask them of me specifically. Here's that question again if you're looking to kind of like reference it or remember it or use it as a study tool. So with that then, we have two ways in which we can determine whether the tests are good or not. Let's just leave it at that, whether the tests are good or not. Reliability is the ability of a particular test or assessment to consistently and over time give the same results, whereas validity is the accuracy of a particular measurement, device, or assessment. So reliability is it consistently testing the same thing over a given amount of time, whereas validity is the accuracy of a particular measurement, meaning, right, is it actually testing what it's supposed to test? So validity is more focused on if I gave you an AP Psych final and I asked you about AP Bio content, right, that would not be very valid because I'm not getting a good answer as to whether or not you know psychology content. But if I gave that same bio test as my final every year for 10 years and got similar scores, right, it could be considered relatively reliable. You are going to actually shift your attention here and you're going to do a formative check looking at different reliability versus validity, and there are different types of reliability and validity that you are going to be looking at. With that said, the definitions are going to be provided in the formative itself, so feel free to take down notes from the formative just so you have the different types of reliability and validity. I'll write them down here so that you can have them jotted down so you know what to expect. But note you will need to be able to determine between these different types of reliability and validity. So hang tight, you have, okay, I just paused it so you didn't have to sit through me writing all that down. So for reliability, you have split half, test, retest, alternate form, and inter-rater reliability. And then for validity, you have content, construct, face, predictive criterion, and concurrent criterion. Again, those definitions are included in the formative, so make sure you're jotting those down if you need to or using the textbook to define them, but you will need to be able to distinguish between the different types of validity and the different types of reliability here, okay? If you have questions, as always, hold them and ask in our Zoom the next time we meet, or feel free to shoot me an email. Thank you, thank you, thank you. You are amazing. Have a great rest of your day. Goodbye.